Smith.
So we're group 7, and for our experiment we compared the movement of 1.5 micron beads in glycerol and water. This was done by tracking the motion of the beads in water for 2 trials and glycerol for 2 trials. Our group took a pipette of water with silicon beads and placed it on a clean slide. This was then recorded with Amscope, a computer device that connects to the microscope. We then repeated the process with silicon beads in glycerol solution on a clean slide. Once all the trials were recorded, the motion of an individual bead in solution was recorded using Tracker, a motion tracking device on the computers. The data from Tracker was then inputted into Excel to make position versus time and velocity versus time graphs. We hypothesized that when comparing the motion of 1.5 micron beads in water and glycerol solutions, the motion of the beads in glycerol would be much slower than that of the beads in water because the glycerol molecules are significantly bigger than the water molecules. Due to the bigger molecular size of glycerol molecules, which is 5 times larger than water molecules, the silicon beads would have less space to move into than in the water solution. The physics behind this phenomenon is diffusion, which simply states the molecules will randomly move from places of higher concentration to places of lower concentration.
We mainly used velocity versus time graphs to illustrate the difference in speed of the beads in glycerol or water solutions. This allowed us to determine in which solutions the silicon beads moved faster. What we found was that the velocity of water in trial 1, which had a speed of 0.1882 meters per second, was faster than glycerol trial 1, which had a value of 0.1868 meters per second for its speed. Trial 2 showed that silicon beads in water had a speed of 0.0829 meters per second, while silicon beads in glycerol trial 2 had a speed of 0.0569 meters per second. Both of these demonstrates that the beads in the water solution moved slightly quicker than the beads in the glycerol solution. The difference between trial 1 and trial 2 for both solutions could have been caused by the layer of beads that our group was focusing on.
With the limitations that we faced during our trial, we did experience quite a few setbacks, such as microscope malfunctions, the number of beads in solution, and technical problems. Our group could not get the microscope to function properly. We had trouble focusing on the actual beads themselves. We also had issues with the number of beads in solution. Our first glycerol solution had next to no beads that we could actually visibly discern. We also tried 2 different tubes of glycerol and bead solution before we found one that actually worked, neither of which had a sufficient ratio of beads to glycerol in the first place. We also had technological problems in terms of Excel. We had trouble accurately creating trend lines and y-intercepts as well, and so this created difficulty in comparing across the various trials and using our y-intercepts and our trend lines to do so across the various solutions. In terms of our conclusions, going forward, we definitely would need more trials to further reinforce our hypothesis. It would also be insightful to compare more than just 2 solutions of differing masses, for example, either increasing our mass from glycerol or decreasing from below water. Keeping in mind that we had significant limitations during our lab, we can conclude that the water solution yielded a faster speed than the glycerol solution due to its lower mass.